That is real-time finger counting, running on a Raspberry Pi 4. In this video, we are building on top of our optimized hand tracking setup to detect exactly how many fingers are open on each hand. I'm going to show you how to write the finger counting logic in Python, how it behaves for left and right hands, and the critical camera optimizations that keep it running at a smooth 8 FPS. Here is how it works under the hood. MediaPipe tracks 21 hand landmarks. For the index, middle, ring, and pinky fingers, we check if the tip is above the PIP joint. If the tip's Y-coordinate is smaller than the PIP joint's Y-coordinate, the finger is open. The thumb is different. It bends horizontally, so we check the x-axis coordinate relative to whether it is a left hand or a right hand. It's a simple coordinate comparison that costs virtually zero CPU time. This is the repository. Link is in the description. It contains the main finger counting script, exact pin requirements, and the privacy recorder. Let me show you how to set up the environment. Step 1. Activate your virtual environment. If you don't have it, create one. Step 2. Upgrade pip first to prevent installation issues. Step 3. Install the pinned requirements. We are using NumPy 1.26.4 to avoid NumPy 2.x API mismatch errors. OpenCV 4.8.1 with v4l2 support and the latest MediaPipe library. Step 4. Clone the repository and run finger_counting.py. Press Q to quit. Let's open the script and look at the key parts that implement the counting logic. The script is 160 lines. At the top, we import OpenCV and MediaPipe and define the fingertip and PIP joint indices. 8, 12, 16, and 20 for tips, 6, 10, 14, and 18 for PIPs. In the count_fingers function, we check handedness. If it's a right hand, the thumb is open if the tip X is less than the IP joint X. For the left hand, it's the opposite. For the other fingers, we loop through the tips and PIPs, checking if the tip Y is less than the pip Y. In the main loop, we read the camera frame, flip it horizontally to correct mirrored coordinates, process it, draw landmarks, call count_fingers, and draw the counts and FPS directly on the frame. Every optimization from the tracking video is here. Optimize camera buffers, model complexity 0, and SIMD optimizations. And here is the final output. Independent finger counting for left and right hands, with the total sum updated in real time. Notice how responsive it is, even on the Pi CPU, without a GPU or cloud backend. Quick troubleshooting. If your thumb counting is backwards, make sure you are flipping the camera frame horizontally using CV2.flip. MediaPipe's left-right classification depends on the camera orientation, so a mirrored image will invert the thumb check. If the tracking is flickering or inaccurate, make sure your hand is fully visible and you have adequate lighting. MediaPipe relies on visual features, and low-light conditions introduce noise that degrades tracking accuracy. If you see import errors like no module named MediaPipe, ensure you activated your virtual environment before running the script. The packages are isolated to prevent conflicts with other system libraries. The GitHub repository link is in the description. If this saved you time, please drop a star and subscribe. In the next video, we'll connect this to a home automation system to control devices with your fingers. See you there.